Can anyone confirm if my screen is visible? Type S in the chat box. If my screen is visible, type S in the chat box. Okay, Darshan. Okay, in the previous class, we have discussed about the Java literals. Let us do a small recap before proceeding with the new topic, which is called as the number systems. So, the literals are classified into 4 types, and these are the categories. One is we can call it as integer literal group, or we can also call it as integral literal group. Floating point literals, Boolean literals, and string literals. These literals are nothing but simply in one word I can say that when you want to represent a data, any data, it can be any data. So each and every data gets identified according to its representation. For example, if you want to represent any numerical values, without including the fractional part, the numerical values can be represented into 4 types. Again, it is again subcategorized into 4 types under integer literal group. So again, they are called as byte, short, int, and long. You will see each and every categorization one by one in the upcoming topics. But the takeaway is, if you want to represent any kind of numerical values without the fractional parts, you can represent it in one of these following categories: byte, short, int, long. Again, which is going to fall under integral or integer literal group. Second one is, and again there is another kind of again one more categorization is there. Char. Char means if you want to represent any single character, any single letter, any single symbol, any single special character, whatever you want to represent. If you want to represent a single element, even the space is also considered as a single element. Space, dot, all these symbols are going to represent. Any symbols, any letters, any number, any single character that you want to represent, you can use char data type. Again, it is going to fall under integral or integer literal group. Very simple, guys. If you want to represent any data, the data can be represented with 4 literals. The integer literal group is going to be used when you want to represent a whole set of numbers without fractional parts. But you can also represent a single character. When you want to do so, you can go for char data type. And so these are the examples that I have given in the last class. So the floating point literals talks about the precision, exact value. For example, the petrol price. The petrol price should be represented with precision. We will also include the floating value, fractional part. For example, let us say the price of the petrol today is, I think, 103 point something, 103.52, 103 rupees 52 paise. You need to include the paise as well. You cannot ignore the paise also. Right? If you have such kind of data, you can go for floating point literals. The floating point literals are again subcategorized into 2 types. One is float, second one is double. Float, if you use float, you are going to consider 2 fractional part. If you are going to use double, the fractional part is going to be very precise, very precise, or very specific. You won't even ignore any part in the fractional value. Right? This is how if you want to represent any precise data with high precision, you can go for float or double. And again, we have Boolean literals. So Boolean literals are going to represent true or false. If you want to check any kind of condition where the condition is going to give you an answer like true or false, any condition, if that condition is evaluated to give true or false, you can go for Boolean literals. This will make more sense when we start developing programs. And the last literal is a string literal. Any sequence of characters that you come across, if you want to represent any sequence of characters, you can use string literal. For example, your name, your address, your location, any character, any sequence of character that you have a requirement to represent any sequence of character in the form of data, you can go for string literals. These are the very basic examples to represent string literals. So after completing these literals, we have just started about the number system. So again, the number systems are classified into 4 types. We have binary, octal, decimal, and hexadecimal number system. So understanding the binary number system is very, very important because the computer is designed to understand only the binary language. So understanding this binary number system is very important. You might have come across this binary number system in your school days, but I am assuming that you are very new to this binary number system, and I will be giving you some inputs from binary number system and how the computers are going to recognize the data in the form of binary number system. I will give you that basic understanding so that it will be easy for us to understand the data types. Right? Let's proceed. So today the topic is going to be number systems in Java. Number systems in Java. So we already know there are many number systems, but we are going to discuss the 4 number system. That is very important. Very important to understand how the memory gets allocated in computers. Very important to understand how the data that we put is getting converted to a number system, and this data gets manipulated internally by the computers, and it is going to process out. That understanding is required. Decimal number system. Binary number system, and we have octal number system, and the last one is hexadecimal number system. Hexadecimal number system. Each and every system has its own importance, right? So you must understand that whenever a number is represented by its base, right? If a number is represented by a specific base, it is going to be called as a specific number system. For example, if you take decimal number system, the base is 10, and for the binary number system, the base is 2. For the octal, the base is 8. The base is 16 for hexadecimal. Right? So let me give you a small understanding about the computers. For example, computers. Hello, my voice is audible.
Excuse me, sir.
Okay. Tell me, Ganesh.
Hello.
Ganesh, tell me, Ganesh.
Sir, your screen is not visible for me, sir.
Okay, 1 minute, 1 minute. Let me reshare. Is it visible now?
No, sir.
maybe there might be some internet issues, Ganesh, from your side. You just try to rejoin.
Okay, okay, sir.
Try to
Sure, sir.
rejoin, it will be resolved.
Okay, sir.
Disconnect and reconnect once again, it will be resolved.
Okay, sir.
Are you facing the same issues, Darshini? Are you able to see my screen? Darshini? Okay, Darshini. Okay. See, understanding this binary number system is very important. We might have understood it mathematically, but the significance of understanding binary number system dates back to the beginning of computer evolution. For example, see, we humans, humans can understand the decimal number system. For example, when I say, right, when I say my salary is 10,000 rupees. When I say my salary is 10,000 rupees, I can understand this because we have a specific value for this 10,000. 10,000 is a value. It is a data. It is a real-time data that is representing my salary. But if you want to make the computer to understand this 10,000, you cannot say that you cannot input just like 10,000. Computer won't be understanding the decimal number system. Computer understands only two numbers. One is 0 and 1. They understand zeros and ones. You take any computer, they understand any data in the form of zeros and ones. All they understand is the sequence of zeros and ones or zeros and ones. Whatever the data that you want to convey or whatever the information that you want to transfer, right? Whatever the manipulations that you want to do with the computers, right? The computers are designed to understand only zeros and ones. The data can be anything. If you ask me, not only the numbers. If you want to transfer, if you want to input this number to the computer first convert this number into the binary number. Firstly, this number will be converted to binary number, and you will pass this binary number to the computer. Right? Likewise, if you have any kind of name, for example, let us take my name itself. My name can be represented in the form of sequence of characters. My name is Balaji, right? So again, this Balaji needs to be converted into zeros and ones. How the conversion is going to happen, we will discuss. Again, the name Balaji will be converted to zeros and ones, so the computer will understand. And if you have any kind of audio, any audio data, for example, let us take a film song. Any film song, if you want to save any film song, this film song is going to get this song needs to be converted in the form of zeros and ones. How the conversion happens? There are some transistors, there are some internal designs where the conversion will take place, but this film song will also get converted in the form of zeros and ones. So this is a typical computer. Whatever the data that you want to share or whatever the data that you want to save inside a computer, the computer will not accept the data directly. The data should be converted to the binary number. Binary numbers are nothing but zeros and ones. Computer can interpret these binary numbers to understand what kind of data you are going to save or what kind of data the computer is designed to manipulate. If you, for example, if you take any video, film song is MP3 song. If you want to save any kind of video, for example, if you want to record my class, you can record this class, but internally computer will, there will be a system where this video gets converted to zeros and ones. How this is going to get converted, that we will understand. But for the time being, whatever the data that you want to save inside the computer, you cannot save the raw data. This raw data This part is understandable by the human beings. This part is understandable by the human beings, but computers, their understanding levels are not straightforward. They understand only the binary language, which is nothing but zeros and ones. This part is this raw data is understood by the human beings. You want to save this raw data, so internally each and every data needs to be converted to the binary number system. You may be wondering how this film song gets converted to binary. For each and everything there will be a code word. For the name Balaji there will be a code word. Again this all the sequence of character will get separated into each and every single letter, and each and every single letter is going to hold a specific numerical value. That numerical value will be converted to the binary data. If you take audio songs, film songs, each and every pitch is going to hold a pitch in the sense audio is going to have a pitch, the range of the pitches. Each and every pitch is going to hold a specific number. That number will get converted to binary. Like video. In the video, each and every pixel, each and every color is going to represent a number. That number will get converted to binary. Whatever the data that you want to manipulate, the raw data needs to get converted to the binary number, so the computer will understand. After manipulating this data, again this data will be converted to the respective raw data, which can be understandable by the human beings. Again it gets transmitted back to the original data. You input something, it gets binary, it will be converting into the binary values, and again the binary values will be converted into the original raw value. It will be given as an output. Making sense, right? So here the takeaway is the binary number system is very imperative because everything in the computers are zeros and ones. So again the data will be converted back to its original form so that the humans can understand. So the takeaway is very simple. I can simply write it like this. All the raw data is understandable by the humans will get converted to the respective binary data. Binary data is nothing but the sequence of data with zeros and ones. Zeros and ones. Each and every sequence and each and every encoding has its own representation, which could be understandable by a machine. And it performs the respective operations or manipulations on the top of data. As simple as that. So it is very, very important to understand the binary number system. So we might have come across this binary number system, but the real cause of understanding the binary number system is that the number system that could be understood by the machine is the binary number system. All the data, any data, the data can be in the form of a number, it can be in the form of a name, it can be in the form of a song, it can be in the form of video. Any data that you are that is visibly seen, or that could be heard, that could be visibly seen, that could be imagined. Whatever the data that you are coming across in a day-to-day life can be converted into the equivalent binary number. They are nothing but zeros and ones. Right? So let us understand what is a decimal number system and why it is important for us to convert to understand the conversion between the decimal number system and the binary number system. I mean to say that why do we need to convert the decimal number system to the binary number system and binary number system to the octal number system and so on. Why these conversions are required, and understand this conversion will help us to understand the memory allocation in the electronic systems. For example, if you take RAM, random access memory, the temporary memory gets allocated temporarily. How the memory gets allocated depends upon the size. Right? So how much size it is going to occupy, all these things could be understood after understanding the binary number system. Right? And I will keep it very slow, because if we understand this concept is not only related to Java, it is related to the computer world. Any language, any programming language you take, this number system is a very significant any programming language, not only in Java, Python, C#, C++, C. In each and every languages, these number systems are very imperative to be understood. Right? So let us understand the decimal number system. So decimal number system is like the numbers that can be represented where human beings can understand. We perform calculations, real-time calculations, by using the decimal number system. Because if you go to the supermarket and if you calculate things by using binary number system, they will usually the accountant in the supermarket, they will be looking weird, right? I mean, they will look at us in a different way if you give the values in the form of binary number system, right? So they don't understand binary, they understand only decimal. But if you observe one thing, they operate on some computer machines. They input the values in the decimal number system, but internally computer will convert the decimal number system to binary, and it performs some additional operations or whatever the calculation that is required. After performing some calculations in the form of binary, and again the output will be displayed in the form of decimal number system. Internally binary calculations are happening. It is performed inside the computer machine. We are not aware of that. You know what? We just input data, we just input values. Computer is designed in such a way that all the values that we are inputting gets converted to binary number system. Modifications or manipulations are done. Then in the console, in the display, the output is going to be in the form of decimal number system. But internally binary calculations are happening. We are not aware of that. We are going to understand that now. So please pay some attention. So now decimal number system, you might be thinking that okay, it is going to be very simple. Understanding the decimal number system is very easy. We have been seeing this for a long time, ever since we started our education in the school. For example, let us say that I have a number like 757, right? So decimal number system is nothing but the base of the number system is what? 10. Even if you put or if you don't put, the base is always 10. When you say that, when you find a number with base 10, so this is a typical number with base 10. Usually you don't see it everywhere, but you can represent 557 like this. It is okay. This is also okay. Both are okay. But you need to assume that if you want to specify that this number is decimal number system, 10 is mandatory for specification. But even if you put or if you do not include 10, it doesn't really matter, because we humans are designed to understand the decimal number system, right? So this 757 can be pronounced like 757. Let me write the way I pronounce. Let me write the way I pronounce. How did I pronounce? How did I just pronounce? 757. This is how I just pronounced 757. Right? I can rewrite this as, I can also mathematically, I can also rewrite this as 7 into 10 to the power of 2 plus 5 into 10 to the power of 1 plus 7 into 10 to the power of 0. Zero. If you see that the significance of power is increasing from left to right. What do you mean by that? The significance of the value of power is getting increased from left to right. So initially it is 10 to the power of 0. It is the second placeholder is having 10 to the power of 1, and the third placeholder is having 10 to the power of 2. The significance of power is increasing from left to right. Right? How it is increasing? It is increasing in the order of 10 to the power of something, which is 10 to the power of 0, 1, 2, and it goes on. If we have 4 digit, it is going to be 10 to the power of 3, and it keeps goes like that. It keeps going like that. Right? So the conclusion is very simple. When you take a decimal number, it is visibly seen that each and every number is getting increased significantly with the 10 to the power of, starting from 10 to the power of 0. If you take, all the numbers can be rewritten with the help of 10 to the power of something. That's why the base of the decimal number system is always 10. That is why I can rewrite it as like the base of the decimal numbers system is always 10, because significance of the power increases from left to right against the number of digits. Digits the numbers. That's right. And if you ask me how many numbers can we use to represent decimal number system, you can use numbers from 0 to 9. To represent a decimal number system, you can use numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can do any kind of shuffling. All you can see is you are going to see the numbers, the complete numbers from 0 to 9. You can write in any way, but these are the numbers that is visibly seen in the decimal number systems. Right? So this 557, I can prove that this is a decimal number system with this simple calculation. The calculation is, take this digit, take the rightmost digit. I mean, it should be right to left. I said left to right, right? It should be right to left. I'm sorry. Right, okay. So take the rightmost digit, 7 into 10 to the power of 0, 5 into 10 to the power of 1, 7 into 10 to the power of 2. So this is going to be what? 7 plus 50 plus Even after the conversion, you are going to see the same number. But the point is, the base is 10. The significance of the power increases from 0 to so on. Significance of the power starts from 0 and it keeps increasing one value from left to right. Sorry, from right to left. Right to left. Right? You take the number, you do conversion with the base 10 and you will get the same number. So that number is called the decimal number system, and the base of the number is 10, and it is going to be, the numbers are going to be from 0 to 9. Very simple, very simple. I don't think the further explanation is required. Right? Secondly, we will understand about binary number system. Let me take this place. Binary number system. See the name itself here, the name itself specifies that the binary number system, the base of the binary number system is 2. See, just see bi. Bi is nothing but, bi is also called as, it is representing something, it is representing 2. Bi means 2. So binary number system, the base of the binary number system is 2. Base of the binary number system is 2. So the binary system, the number system which can be represented with two numbers. Two numbers, one is 0 and the second one is 1. 0 and 1. Apart from the, without, you can either use 0 or 1 or the combination of zeros and ones. You cannot use any other numbers apart from 0 and 1. So the number system is going to represent with the two numbers, zeros and ones. They are called as binary number system. They are used by the machines to perform manipulations. So the base of the binary number system is 2. Let me take a small example. See, in any computer, in any electronic device, let us say that I have a laptop. My laptop has a RAM of size 4 GB. Let us assume that this is my system. In my system, I might be having several configurations. Many configurations. You might be having a hard disk. You might be having SD card. SD card, hard disk, both are same. RAM, processor, and we also have the chips, Intel chip, Ryzen chips. So many internal stuff shall be there. They are assembled together to form a computer. The computer is not a single entity. There are several components inside. All these components are assembled together. We call it as computer. Computer means nothing but computing calculations. Right? If I have a RAM is random access memory. Let's say that if I have a RAM, the size of the RAM is 4 GB. The size of my computer RAM is 4 GB. So RAM is nothing but the temporary memory or the random access memory. The memory that gets occupied temporarily for a particular application usage or any kind of functional usage. The RAM comes into picture. In real-time example, if you open Facebook is going to occupy the memory from the RAM. It is not going to occupy the memory from your hard disk. the RAM part will be utilized for the temporary purpose. So you can fetch data. For if you open Gmail, Gmail is going to occupy the RAM memory. Whatever the applications that you try to open in your system, RAM memory will be utilized. Temporary. It is going to be temporary. As long as you use, it is going to consume some memory. Right? And when, so if anyone is asking you what is the smallest memory, what is the smallest unit of memory that any electronic chips or any machines can come across. 4 GB is something, it is a very big memory, and even I may be having 4 GB of memory, but your computers may be holding up memory up to 8 GB, sometimes 16 GB RAM. The size varies from computer system to system. In olden days, the RAM size were up to 512 MB, right? The sizes are very small in the previous days. Right now we have an option, and the evolution is in such a way that the RAM capacity is getting increased day by day. Depends upon the price, and it depends upon the financial entities. If you can afford the big computers, you can afford big memory of RAM, and big size of RAM size with huge amount of memory. So 4 GB is a memory that is possessed by my laptop. But if anyone is asking what is the smallest size of memory that a computer or any electronic device can occupy, answer is very simple: bit. Bit is a smallest memory unit, smallest unit of memory. Okay, used to store a data. Bit. This is the most common answer. What is the smallest unit of memory that anyone can mean that can be used to store a piece of data? Bit. 1 bit. 1 bit. So let us understand that this is a bit. Just an assumption. This is 1 bit. And if you want to store a data, if you want to store any data, and the size of the memory is what? 1 bit. So here we are not talking about the RAM. The size of the RAM is 4 GB. But if you have any memory component of size 1 bit, bit is the smallest size. 1 bit. What kind of data that you can store in this 1 bit? There are 2 possible values that you can store in this 1 bit. What are the 2 possible values? One is 0. One is 0. Two possible data. One is 0. Second one is 1. At any point of time, we can store any one value among these 2 possible combinations, 0 or 1. If you have a 1 bit of memory, you are allowed to store only 2 values. One is 0, second one is 1. It is the smallest piece of memory. Smallest piece of memory that anyone can connect. So there is no smaller than this. There is no memory smaller than this. Anyone is asking what is the smallest piece of memory in electronic devices or any computer devices, you can say that 1 bit is the smallest piece of memory, where you can store 2 possible combinations. One is 0, second one is 1. Why we are discussing all this, sir? If you ask me, we are trying to understand the binary number system, the evolution of binary number system. So what we will get by understanding binary number system, we will get to understand how the memory is getting allocated for each and every data that we come across. So to help us understand the memory allocation, we need to start from the beginning, isn't it? That's why I'm teaching you the bits, bit manipulations. Right? So in the 1 bit of memory, you can store either 0 or 1. At any point of time, you can store 0 or 1. But 2 possibilities are there. You can either store 0 or you can either store 1. So this 0 can also be represented as true, false. True, false. false. 1 can also be represented as true. So you don't put true directly. Instead of using true, you will use 1. Or this false can be represented as no. True can also be represented as yes. These are the possible values. False can be also represented as off, and this can also be represented as off. So the evolution of computers started from here. They started doing some optimizations and improvisations on computer language just by utilizing the concept of bit. Right? So the computer is designed to understand the values in the form of bits, either 0 or 1. If I have a computer that has a memory capacity of 1 bit, so my memory in my computer, I can either store 0 or I can either store 1, depending upon the circumstances. 2 values I can store. In the earlier days, before the evolution of computers, information is transmitted in the form of bits. For example, let me give you a small story. Before the World War I and during 1800s, people used to transmit data, communicate with each other with the help of lights. Simply, I can say that with the help of bulbs. What is a bulb? You know the bulb, right? Let's assume that this is a bulb, a glowing bulb. So data is transmitted using this bulb. For example, if I am a person, I'm living in a city. I do not have access to computers because computers were not discovered in those days. A person living in a city, and I have a friend who is my relative who is living in a forest. Just an assumption. This is me. This is my relative. He is living in a forest. I am living in a city. Right. So the distance between us is about let us say 10 kilometers. Not a practical distance. It is a very long distance. 10 kilometers is very long. In those days, we don't have the connectivity. The automobile, transportation was not good, and we don't have Ola cabs or things like that, right? To communicate, and we don't have telephones. We don't have WhatsApp. Everything was limited. The access to technology was completely limited because technology was not up to the mark, right? So if I want to communicate with my relative who is living in forest, my relative is living in a forest. Living in a forest. I am living in a city. This is me. I am living in a city. So my relative, he don't have any access to any electronic device because the discovery was not up to the mark. So we have access to what? We have access to a bulb and an electronic switch. I have the switch control with me, and my friend who is living in the forest, so he has a bulb. And this bulb and switches, they are connected. The circuit is closed with the help of a connection, right? So I can deliver 2 messages to my friends. One is I can tell him 0, or I can tell him 1, or I can tell him false, or I can tell him true. Whatever the input, if I turn on this light, if I turn on this switch, if I keep this switch turned on, it is like I am just passing him a message that I am in trouble. If I turn on this switch, I am just giving information in the form of the what electrical equipment. I'm just passing an information. If I turn on the switch, The bulb turns on, the bulb starts glowing, and my friend will recognize that, okay, I'm in trouble. He will come to my rescue, and vice versa. Sometimes you can keep the bulb here and you can keep the switch here. These positions can, or you can keep a bulb here and you can keep another switch here. Right? Two information I get close. If I turn on the switch, the bulb glows, my parent will recognize, okay, I am in trouble, so he will come to my rescue. If I turn off the switch, it means I am safe. So the bulb will not glow, right? That if I turn off the switch, the bulb will not glow. It means it is representing that I am doing safe. I have no issues. Right? So here internally what is happening? We are making a communication, not a direct communication, an indirect communication where I am passing the data in the form of two values. I am allowed to pass, I am allowed to turn on, or I am allowed to turn on. These two values I can. So this is the practical representation of 1-bit data. It's a practical representation. If you want to represent this 1-bit practically in the real time, 1-bit is nothing but if you have a switch, connect the switch to a bulb. With the switch, you can perform two operations. One is turning on, second one is turning off. Turning on is like you are keeping a backup message. For turning on, if the switch is turned on, it is like you are giving information like you are in trouble. Turning off, you are safe. This is a real-time example of 1-bit information. So this particular part, this particular thing is called as what? A transistor. This particular thing, the combination of switch and the bulb, we call it as what? A transistor. Transistor. So with one bulb and with one switch, you can pass two information. The combination of 10 bulbs and 10 switches, you can pass many information. You can code a huge amount of information in the form of binary numbers. Hope my example is making sense. So the simple 1-bit representation in the real-time analogy is just like communication between two persons with the help of a switch and the bulb. A switch you can use the switch to pass two information. One is on, second one is off. Off means you are safe. On means you need what? You need you are in emergency. You need help. Right? If I have two switches, I can pass 4 information. Right? One switch, 2 information. So I can write it like this. One bit. Just assume that 1-bit is nothing but you have a one switch. One bit. You can pass two information. One or 0 you can pass, or you can pass true or false, or you can pass on or off, or you can pass yes or no. All these categorizations are one and the same. If I have 2 bits, if I have 2 switches and if I have 2 bulbs, you can pass 4 information. Right? So 0 0 I can pass. I can keep the 2 bulbs turned off, or I can either keep one bulb turned on, second bulb turned off. I can keep the other one turned on, second one turned off, or I can keep the bulbs turned on. So when you say that your memory size is of 2 bits, so you are potential enough to pass 4 combination of informations: 0 0 0 1 1 0 1. Right? This can be what you can use this analogy to transmit 4 kinds of information: 0 0 0 1 1 0 1, which can be also called as false false, true, true false, true. If you have 3 bits, when you say 3 bits, You can pass 8 combination of information. 8 combinations. 0, 0, 0. It goes on. It keeps going like that. 0, 1, 0, 1, 0, 0, 0, 0, 1. Let me write this one. 1, 0, 1. 0, 1, 1, 1, 1, 0, 1, 1, 1. So 8 combination of information can be passed with the help of 3-bit circuit. Right? Likewise, it keeps going, isn't it? It keeps going. And at one point of one point of time, they have just they come to conclusion saying that the combination of 8 bits is going to be what? 1 byte. 1 bit. And the size keeps increasing, and the combination of some of the bytes is going to be 1 megabyte. Combination of some of the megabytes is going to be 1 terabyte, 1 gigabyte, and it keeps going. But the smallest value is what? 1 bit. 1 bit is the smallest representation. With the 1 bit information, you can store 2 values, zeros and ones. So whatever the bits or whatever the size of the memory that you're going to take, all the informations are stored in the form of binary values. That is the takeaway. You can either you are allowed to store only the binary value, combination of zeros and ones. Even if you say 4 GB of data, 4 GB of RAM space, if you are saying that your computer is equipped with 4 GB of RAM, it means that it is going to store the 4 GB of memory at any point of time, and the 4 GB of memory is going to be represented in the form of zeros and ones, which is a binary number. The text, the audio, the video, everything will be in the form of binary data. How it is going to be in the form of binary data, that we will discuss. But for the time being, just understand that all the data that you are required to store in the computer is going to get converted to the binary data, which is nothing but zeros and ones. Just simple real-time analogy. Right? This is how the binary information can be used to transmit or can be used to communicate between two persons. Real-time analogy. You have a switch, you have a bulb, and the switch can able to you can use the switch to communicate with the person who is living in a different place. By turning it off, you are passing a message, and by turning it on, you are passing another message. You can pass at most 2 messages at any point of time. At any point of time, you can pass only 1 message. Maximum, you can pass 2 messages, but at any point of time, you can pass only 1 message. 2 combinations are possible, but a maximum at any point of time only 1 information can be passed. 2 combinations, 1 information. So if you take 2 bits, 4 combinations, 8 combinations, 4 combinations, and 2 set of values at a point. False, 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 true. Like that. If you take 8 possible combinations, 3 information you can pass at any point of time. Making sense? We will discuss more about this decimal binary number system. So this is the foundation level of understanding a bit. Someone is asking what is a bit? Bit is the smallest unit of memory. Even though if you talk about a bit, if you talk about bytes, if you talk about gigabytes, megabytes, all the data, internal data is going to be in the form of binary numbers. It's going to use the binary number system. When someone is talking about the memory, I blindly tell them that they are talking about what? Literally they are talking about the binary number system. Because internally the memory is debugged or converted to the binary number system. Memory point of view. If you talk about memory point of view, you're talking about the binary number system. Right? So this is a basic introduction to the bit and the binary number system. Going forward, we will discuss the conversion between the decimal to binary to octal. We will try to understand the various conversions. Right? After understanding these conversions, we will also understand some problems. the real-time problems, then we will start discussing about the data types. That will make more sense. These things will, I mean, you are not going to see these things anywhere in the textbooks or whatever, wherever you come across. I'm just trying to link this topic to the data types, so that understanding the memory allocations is going to be very easy. You will not face any issues, right? Any doubts you have?